So let me first give you a brief background on what is very quick update on what is moderation. So moderation diagrams are always drawn like this. Okay. Mediation we saw yesterday, mediation models are always drawn like this. So we had leadership, PJ, and creativity. Whereas moderation, you talk about X, MO, and this diagram, this is the conceptual diagram. The statistical diagram translates to you have X, moderator, and X into the moderator, right? This becomes your model. And so when you write, we can call these as beta 1, beta 2, and beta 3. So when you write the equation, it becomes constant plus beta 1 times X, beta 2 times moderator, beta 3 times X into the moderator plus the error of E of Y, right? So this can actually be written as we can combine this moderator plus beta 1 plus beta 3 times moderator whole times X plus E of Y. Now the slope of this line, right? So theta X on Y, that is the effect of X on Y, is conditional upon the value of the moderator in this case, and it is denoted by B1 plus B3 moderator. So let's say moderator is a dichotomous variable here. So let's say it takes two values, 0 and 1. So theta x to y, theta x to y for MO is equal to 0 becomes beta 1, and theta x to y for moderator is equal to 1 becomes beta 1 plus beta 3. So what happens in a moderation model, if you were to plot the relationship between X and Y, you will see that you get different lines. This is Y is equal to beta 1 plus beta naught plus beta 1 times X plus E of Y. This is for moderator is equal to 0. This is the slope of the line, beta 1. This is the intercept. If you were to plug in M is equal moderator as one value in this equation, in this particular equation, what do you get? You get beta naught plus beta 2 and beta 1 plus beta 3. So this equation becomes now beta naught plus beta 2. This is the intercept, and beta 1 plus beta 3 times X plus E of. So moderation, in moderation, and why is moderation tested or used or done in research? Because moderation helps you understand variables or conditions that will change the magnitude of these relationships. So when moderator was not there, the relationship between X and Y was beta 1. But when moderator is there, the relationship has improved or increased, which has become beta 1 plus beta 3. I am here assuming that beta naught, beta 1, beta 2, and beta 3, they are all positive. They are greater than 0. So this would be the kind of a chart that you would see. So moderation testing, moderation always helps us understand what variables, or what are the conditions that actually help us change, or what are the conditions that change the relationship between X and Y. In mediation, remember what did we say? We said that the total effect never changes. Mediation breaks it down into two effects. So this was the total effect, this is the direct effect, and this is the indirect effect, right? So mediation does not change the total effect. The total effect remains the same. However, in moderation, actually the effect changes. It becomes beta 1 plus beta 3 times MO. So what is the test of moderation? Let me also tell you this. The test of moderation is if this coefficient of the interaction term, that is x into MO, right? X into MO. The coefficient of this term, beta 3, whether this is 0 or whether this is different from 0. Because only if beta 3 is different from 0 will this effect change. Irrespective of irrespective of what happens to beta 1, beta 2 in the equation, whether the coefficient of x, that is beta 1, is significant or not, or beta 2, that is the uh, direct effect of moderator on y, whether that is 0 or not, that does not matter. What you will have to check when you will be testing moderation is whether the coefficient of this term, of the interaction term, x into MO, is 0 or is it different from 0. Only if it is different from 0, that you can comment that there is a significant moderation in my data, right? So in order to test the moderation, that is how you will have to proceed in your model.